Okay, we're now going to cover day 2 of section 9.3, which is converting between rectangular and polar equations. Okay, we're going to be going back and forth. So we're going to start with converting from rectangular equations to polar equations. And to do that, we're going to need to simply do some substituting. Okay, we know from our last lesson that y is equal to r sine theta. And we also know that x is equal to r cosine theta. And so we're going to be taking our rectangular equation and plugging in for y and x. Okay? Algebra 1 scale. We're going to be substituting. Then we have to solve. And our goal at the end is to solve for r. So it's in the form r equals something, function, something. Okay? So that is the game plan. And so we're going to start with an equation. Y equals x squared. Okay? And when we go to solve this, we got to substitute for y. We're going to put in r sine theta. And for the x squared, we are going to be putting in, for the x, r cosine theta, and it's squared. Okay? And we're just going to manipulate it a little bit. So we have r sine theta, get rid of the parentheses, r squared, and then cosine squared theta. Okay? We have r's on both sides, so if we divide both sides by an r, we know on the left the r's cancel, and on the right, the r on the bottom gets rid of the square. So we're left with a single r. So we're left with sine theta equals r cosine squared theta. And now to get r by itself, because that's the game plan, is to get r by itself. It's going to be on the right instead of the left, but we can flip the whole thing later. We simply got to get rid of what's attached to the r. So it's being multiplied by cosine squared theta. To get rid of it, we're going to divide by cosine squared theta. And when we do on one side, we do on the other. Okay? At this point, I'm going to flip my sides around. Okay, so on the right would have been the r, I'm moving it to the left, and on the left would be the sine theta over cosine squared theta. Well, we need to reduce that a little bit. We don't normally leave trig functions like that. If we rewrite it as sine theta over cosine theta times 1 over cosine theta, so we break up the denominator, right? We have that sine over cosine, we know that is equal to tangent of theta. And we know that 1 over the cosine of theta is the secant of theta. So our final equation, r equals tan theta secant theta. Okay? Not hard math, but it's going to tie back into some of those trig functions we were using last semester, knowing just how to manipulate them across. Okay? Let's look at another one, a little more complex this time. We have x minus 4 quantity squared plus y squared equals 16. Okay? It's going to take some plugging and chugging, but it's not hard math. Okay, this is all math that should be within your well house. So when we plug in for the x, r cosine theta minus 4 quantity squared plus r sine theta quantity squared equals 16. Okay? Next thing we got to do is evaluate those. Okay? When we evaluate this, we need to basically FOIL it out. So we're looking at r cosine theta minus 4 and r cosine theta minus 4. So first terms squared would be, or first term times first term, r times r is r squared. Cosine times cosine is cosine squared theta. Then our next term, the outers, negative 4r cosine theta. The inners are a negative 4r cosine theta. And we know that these are going to combine in the next round, right? And our last term's negative 4 times negative 4 is plus 16. And that takes care of the first part. Now to take care of the second part, we have to just simply go through and square this. R squared sine squared theta. That's what's coming from there. And then the equals 16 just comes on down. Okay? Now we can do some simplifying. 16 on both sides, so it's being added, so it cancels out. That leaves a 0 on the right-hand side. These two terms are going to combine, so when we into a negative 8r cosine theta. So when we rewrite this, we are going to have r squared cosine squared theta minus 8r cosine theta plus r squared sine squared theta equals 0. Now, like we saw in the last problem, where at some point we're going to have an r on one side and an r squared on the other, and we're going to be able to divide through by an r to get rid of the r's, we're going to be able to do something similar here. Okay? But to do that, we have to get our r squared terms on one side and our single r term on the other. So we're going to add 8r cosine theta to both sides. That will give us r squared cosine squared theta plus r squared sine squared theta equals 8r cosine theta. Okay? Now that we have this brought together, we see that we have a cosine squared and a sine squared being added together. Well, we remember from trig, we can get rid of something that looks like that. But we gotta get rid of these r squareds. So if we factor the r squareds off the terms, we're left with cosine squared theta plus sine squared theta inside. And what do we remember that equals? Sine squared plus cosine squared equals, look it up, you may need your identity chart from last semester. Sine squared plus cosine squared equals 1. So this whole thing just became 1. So we're left with r squared equals 8r cosine theta, and at that point, we can simply divide by r. These r's cancel, this r cancels with the r squared, and we're left with r equals 8 cosine theta. Okay, a lot of work, but all math we are familiar with. That's the harder direction. Okay, going the other direction, kind of easier. So let's look at some of those. So now we're going to convert polar equations to rectangular. Okay, this time what we need to remember is that wherever we have an r, we can put in the square root of x squared plus y squared to convert it to xy terms. So if we're given r equals 7, then when we plug in the square root of x squared plus y squared equals 7. To get rid of the square root, we're going to have to square both sides, so we get x squared plus y squared equals 49. Okay? If you can solve for y, do so, but in this case, it's not going to solve pretty for y, and so we can leave the x squared plus y squared right here. This is actually the equation of a circle. And we're going to learn about those in the next chapter. Okay? So this is kind of a precursor. We're seeing these equations coming out from polar to rectangular, and then we're going to actually start manipulating them next chapter. Okay? Let's look at one more. If we're given one where theta is equal to pi over 6, so we're given an angle that's going to produce us a line, whereas radiuses produce circles. So we're going to be producing a line this time, and we remember that theta, that the tangent of theta is equal to y over x. Okay? And so we need to find what the tangent of theta is here. So the tangent of pi over 6, we know that the tangent of pi over 6, if we look at our chart or our unit circle, we're going to see that the tangent of pi over 6 is equal to root 3 over 3. Okay? That's easy enough. Well, if that's equal to root 3 over 3, that's the same as being equal to y over x, because we know that the tangent of theta is equal to y over x. So that means we can set this equal, and if we get y over x equal to root 3 over 3, we multiply the x over, and root 3 over 3 is our slope, times the x. There's no intercept because it'll go through the origin. And there's our solution. So that finishes up chapter 9 on polar equations and the converting between polar and rectangular. Next chapter, we're going to start conic sections. See you then.